1971, Glowworm introduced the world to the first ever wall-hung cast iron heat exchanger boiler called the Space Saver. What I remember of it is didn't save any space. Anyway, in 1999, Glowworm introduced the world to this boiler. Now this is the Glowworm MICRON, and when it was introduced it was said to have been the smallest cast iron heat exchanger wall hung boiler in the country. Don't look very small though, does it? Because this one is the Glowworm MICRON 100 FF. The smaller ones were the smaller kilowatts. So this was introduced in, like I said, 1999, and then was taken away from the world in 2006 due to the changes in condensing boilers. So this is a 2005 model, so this is pre-condensing boiler. So my name is Derek Robbins from Tomcat Gas Training, and this is inside a boiler casing on the Glowworm MICRON 100 FF. So as usual on Tomcat videos, we're going to start at the turret. So let's get on with it. So before we crack on with the video, let's get the disclaimer out of the way. So first of all, you must be gas safe registered before you can work on gas boilers. This video is designed for trainee gas engineers working alongside already qualified engineers for their portfolio, or it could even be for gas safe registered engineers who've never worked on the Glowworm MICRON before. So also in this video, some of the clips you'll see were filmed before lockdown. So now the disclaimer's out of the way, we can finally get on with it. So this is the turret. Slightly different than the turrets you've been looking at in all the other inside a boiler casing, because the flue on this one is aluminium on the outside and it's also aluminium on the inside. So you can actually see that down there. So you can see it's aluminium on the inside as well as the outside. This is our flow pipe, and if we look around there you can see our return. And this is the clip what holds it on. So there's a bracket which goes across the bottom of the boiler to hold it up, and then this stops it falling off the wall. So you basically put a screw in, close that down, and then screw that up. So that's basically the top of the boiler. Now this is the flue terminal, and you can see it's got a bit bashed when we were taking it out. But this is the restrictor. So all the Microns came with a restrictor. Now the smaller size, like the 50 FF, this would come with a restrictor in a bag which you used to have to fit yourself. So when I was fitting these for the council, we used to have to put these restrictors on, and then you go back the year after and the restrictor's gone. So what they did in this one is it's actually built in to the flue, so it doesn't fall off. So I was fitting them for the council in about 2003, something like that. So these restrictors were important to the boiler's flue length. So you had to fit them if they was going out through the standard rear flue, and if it was on a flue extension then you didn't need them. But this flue was actually virtually over length as well. So we could only go 3 meters with this flue system. So that's the flue restrictor and the flue terminal. So if we work our way down now, you can see the fan. So here's the fan. At the back here we've got our low water pressure sensor, and if we go across the other side you can see our high limit safety device there in its file. So if that goes over temperature it will knock off and it activates this little thing down here. So if this, for the want of the better word, sticky out bit here is sticking out and you can press it in, and that means that high limit stats have activated. If we come down, you can see this is the boiler thermostat, which will make and break the electrical contact here. So this is whatever you set that to. Once it gets up to temperature there, it will actually knock off. So pretty straightforward. It just turns the power off to the gas valve. So you can see the fan tubes, which then come all the way down here, come to here and go across to the fan pressure switch. So you can see the Honeywell pressure switch there. So this is the burner. You'll see the heat exchanger is cast iron heat exchanger. So this is what we call a high water content heat exchanger, but it still only has about 4 litres of water in it, so nothing spectacular. And if we come down now, we can see our pilot assembly. So there's our pilot assembly viewport, and this is all the pilot assembly. We're going to see this all stripped down soon, and then we come down to the gas valve. So let's have a look at this gas valve a little bit more closely. So you can see on this side here, this is the isolation valve, and when you can see that line going straight across, that means the gas is on, and if we turn it upwards like that, that means the gas is off. So this test point you can see down here is our inlet test point. So we can take our inlet pressures, and if we go across to here, this one here is our burner pressure test point. Okay, this is our solenoid valve. So this is kind of a multifunctional gas valve, because you've got your solenoids there, and it can regulate, because if you just go to the back there, so we can adjust this gas valve here between minimum, mid and maximum settings. So on minimum setting, it will give us about 23 kilowatts. On mid set, it would give us 26, and maximum it would give us 29 kilowatts on this 100 FF. On this side here is where it goes through to the burner. This is your pilot. So this is your pilot tube, go into your pilot tube. So that's the gas valve. So that's the components on this Glowworm MICRON 100 FF, and the FF standing for fan fluid. Now this is where the video is going to be a little bit different to the ones we normally do on inside the boiler casing. We're actually now going to go on site where this boiler was installed and have a look and see why this boiler is here and why we ended up having to replace this boiler. So let's get on to Derek on site then. Now, been called out to this Glowworm MICRON, which isn't firing up. So let's get the cover off and switch it on and see what's happening. Ooh, not doing anything. Okay, let's get the covers off and let's have a look. So before we take the covers off, let's have a quick look around. Let's have a look at this flue first. Okay, so there's no brackets on the flue whatsoever, but it does look like one full length of flue. So if we look down here, we can actually see the boiler has been installed onto a sealed system. So this boiler can go on a vented system or sealed, but they've sealed this one. Let's have a look at the controls. We've got one pump, we've got an automatic bypass. See our flow and returns going up there, and we're on two port valves, so we're on an S-plan system. So that's what we're dealing with on this installation. So let's start stripping this boiler then. Always make sure before we work on a gas appliance that we make sure there's no stray voltage on the actual appliance. So we need to use our non-contact voltage indicator. So we need to prove it. Then we need to use it on the pipework and on the appliance. And then once we've used it, we come back and we prove it again. And obviously, if we are going to go into the electrics, we need to follow our safe isolation procedure. Now, removing the cover is pretty straightforward. First thing we need to do is take this bottom out, which is just basically on a slide. So it slides on 2 slides down the bottom. And then here, what we've got is, we should have a wing nut on this side and a nut on here. The reason why there's a wing nut on this side is so you can get your fingers in to do it, and on here there will be a spanner. So once you've undone that, I've already taken them off, and then it just unhooks from the top and lifts down. So this hook here seals, goes up on the top up here, so it just hooks up. You should be able to see the seals there. So that's the seal on the casing. This is a negative pressure boiler, not a positive pressure boiler. Okay, so that's how you take the casing off, dead easy. Now we've got this front cover off, let's have a closer look inside and let's see why this is not firing up. So we need to remove the combustion cover. So what we've got is 3 10mm bolts on this side, 3 10mm bolts on that, and 2 Phillips screws here. So I've got my little Weir socket. And then undoing these 2 screws here. And now it's just a matter of lifting it off. It's easy as that. Now, first thing I've found is that is the low water pressure sensor at the back there, and it has been bypassed. So that's the first thing I found. So need to get a new one of them for see if we can get one. And the next thing is, the reason why it's not firing up is this wasn't attached. So there's no gas going to the pilot. Okay, so it was just hanging out. So we need to get a new olive for that. Need to see if we can get the spark electrode to sort out, make sure we've got some flame rectification, and we'll give the old girl a good service. I've just looked at the data badge. This was manufactured in 2005. So let's get off and get the bits. Let's get it stripped. Let's get it serviced, and let's see if we can get the old girl back together again, working. So I said earlier this boiler could go on a open vented or a sealed system, and it basically says in the instructions if it's on a vented system, so it's an open vent, and the open vent is to protect the boiler from going over temperature and pressure, it says you can bypass the low water pressure sensor. But we are on a sealed system, and it says if you're on a sealed system then you will require these cables to be connected. So technically we have an immediately dangerous situation, and we've got an ID situation because we've got a safety device being made inoperative. Okay, got the covers off. That needs a good cleaning, the old heat exchanger. Get them baffles out and give them a good cleaning. One thing I've noticed is a massive big crack in the back of the insulation at the back, so that's going to have to be replaced. Okay, and managed to get the spark electrode out, and this is the condition it's in. So flame rectification, I've got a complete new one and all the new fittings, but this is going to need a good clean up. So let's get it cleaned up, get a new olive on there, get all this cleaned out, and I'll have to go out and get some new insulation for the back. Let's see if we can get it up and running. So removing the pilot assembly is quite easy. So the first thing we need to do is get a 12mm spanner on here. Now this boil has been was left out in the garden. So this is why everything looks pretty damn rusty now. So you can now see the olive, which was snapped off before. So that's that, and then all we need to do now is get an 8mm spanner on this nut. Just takes the cover off and removes the pilot assembly. So, got the flame rectification electrode out, okay, but somebody has been messing with this because the injector's just loose. So, we've got all new out for this. So we've got a complete new injector housing and O-ring, olive, to fit on our pipe there. So, let's get this burner out now and give it a good clean up. Removing the burner is just as easy. You can either remove it from that nut there, or using a Phillips screwdriver, we can just get on this nut here and the old burner will come out. As simple as that. Now I've got the burner out, see the injector at the back there. You can see how badly damaged this back insulation is. So I've started taking the first 2 rows of baffles off, but they're in a pretty bad state. So you can see the state of that one. I'm just putting them over here in order so I don't get them mixed up. So you can see they're the first 2 that have come out. And now we just got to get... So I don't think this has had a service in a while. I can now get my brushes and my hacksaw blades and clean all that up and get all the debris out the bottom. So, vacuumed and cleaned up all the baffles now. So they're all ready for going back in. Also cleaned all the heat exchanger now, vacuumed it all out on the inside. So I've had to order this piece here, so that should be coming later, but we're going to put it back together again and try and get it all up and running. So next thing now is get the trainees have just got off doing all the visuals and tests and stuff on the gas for their portfolio, and we're going to get this up and running. Let's get on with it. So to remove this low water pressure sensor, obviously we've got to drain the water out the boiler, which we've done from the drain point down here. So that's how you can drain the heat exchanger. So we've got the water off, we've drained it, and all it is undoing it, because you literally can't get a spanner in. And then replace it with the new one. So that's how easy it is to do the low water pressure sensor. Okay, we've got it back together again. Put the pilot assembly back, put all the new injector in and the new olive. We've reconnected the low pressure system. We've just filled the system up. This house is huge. Okay, let's fire it up and see if it works. Hey! Better turn it off because there's no front cover on. So it ignited and we had a good pilot and everything seemed to work. So low water pressure sensor worked. Happy days. So get the covers back on and let's get it tested. What do you think, boys?
Fab.
Now, you've just seen that we actually got the old girl up and running. But if you want to find out why we ended up changing this boiler, then you're going to have to wait till Wednesday when we release our video on low loss headers. So look out for that one on Wednesday. Now that is the end of this inside a boiler case video on the Glowworm MICRON 100FF. As usual, if you've liked this video, why don't you give us that thumbs up or leave a constructive comment down below. Not about me sticky out ears and me teeth and all that kind of stuff. That's not a constructive comment. You know, whether you think the boiler's rubbish or not, that's a constructive comment. Not what I look like. Anyway, where was I? If you're not subscribed to our channel, then please subscribe because it helps. And don't forget to hit that notification bell because YouTube will tell you when we've released new videos. It's mainly on Mondays and Wednesdays. So all I've got to say is, thanks for listening, thanks for watching, and thanks for your constructive comments. And I'll catch you on the next one, guys. Cheers.